These three pendulums have different amounts of limbs. The red one is a double pendulum with 2 limbs. The blue one is a triple pendulum with 3 limbs, and the purple one is a quadruple pendulum with 4 limbs. All of the three behave chaotically, but to different degrees. In this video we will show you that the amount of limbs matters for how chaotically the pendulums behave. To see this, let's simulate 5 pendulums of each type, each of the 5 initiated with slightly different angles. As you can see, the pendulums with more limbs diverge slowlier. While the red double pendulums separated very quickly, the purple quadruple pendulums stay together for a long time. It takes until here that the purple pendulums start to diverge. To see this even more clearly, let's simulate the pendulums next to each other. At this point, the double and the triple pendulums are already in a state of chaos, but the purple pendulums are still indistinguishably close to another. The degree to which a pendulum is chaotic can be measured by the so-called Lyapunov exponent. What the Lyapunov exponent is and how we can apply it to these pendulums remains a topic for another video.